Hello. This presentation is maybe designed to show you what you might not know you didn't know regarding the services that are available over the web. So if you don't have tools, but you do have a community of makers, how can you actually make parts that you can hold in your hand? Or if you do have tools and a great workshop, how can you augment your tools with other third-party service providers? So here I list a handful of service providers that can do everything from laser cutting of wood and plastic to metals to abrasive water jet to 3D CNC machining to creating your own manufacturing cell to 3D printing and electronics. You can even have a printed circuit board mailed to you. We can even design IoT devices and mobile apps and more. So we'll start with Ponico, which is a website where if you have a 2D file, you can email them the file and they'll mail you back your plastic parts, or they'll even do 3D printing for you. Send Cut Send is a service that you can send a two-dimensional file and they will ship you back a piece of metal laser cut out of a variety of different materials, from copper to steel to titanium and more. Yeah, this is a remarkable way to be able to laser cut steel without having to spend hundreds of thousands of dollars to have such a laser in your shop. There's also Xometry, which is a water jet cutting service, so you can also cut metals or even glass or granite and ceramics and things like that. And there are different reasons you might use a CNC to cut metal versus a laser to cut metal, versus a plasma cutter, versus a water jet. So you can have your pick of these resources when you need them without necessarily having to spend the money to buy them yourself and to maintain them. So if you can wait a week or two for these parts to be shipped to you, these are amazing resources to add to your capabilities. Vention is a really interesting space where you can design a machine, essentially, and they will send you all the parts to assemble yourself. So here, if I click on this, we can see that as we add components, you can click and drag struts or plates or even motors and sensors, and as you add them to your device, it's actually calculating how much you're spending. So you have an idea how much this is going to cost when you order it, and then again, they ship you all the parts. What's nice here too is that they actually send you all the parts in a way that they don't need to be welded. Rather, you can use Allen bolts to put the whole thing together, just with one or two people and a few hours. So this is a really remarkable way to be able to build your own assembly line, manufacturing cell, machine, etc. Fictive is a 3D printing and CNC machining service. So again, you can email a file and get a quote to see how it would be 3D printed or machined out of a variety of materials. Really useful functions. And they will even help you do things like plastic injection molding rapidly and cost effectively. Shapeways, of course, is one of the original 3D printing services where you can have models uploaded and then quoted almost instantly, so you know how much these things will cost. You can adjust your file to reduce the weight and hence to reduce the cost. So if you have a 3D shape, perhaps you can put some holes or gaps in it that wouldn't affect the performance but would lighten the weight so that it's cheaper. Or if you have a solid object, you can create a hollow cavity, again to reduce the cost. So this is a very clever way to be able to hold 3D parts that you've designed within a week or so, and you don't have to go through the process of owning your own 3D printer, spending the hours to print the part, cleaning it up, etc. They ship these back to you pretty much all cleaned up. And they will also do things like cast out of metal using the lost wax process. So you can send a 3D shape, they will print it in wax and make a mold that they can then pour metal. So this is good for jewelry. It's also good for functional parts. Really remarkable, the types of products that Shapeways is making these days. And then Arduino, of course, is the enormously popular embedded control electronics platform, where you can not just learn to code, but buy many cost-effective components, from sensors to motors to housing and things like that, LEDs and other fun. And there are many different unique niche products where if you want to control a string of LEDs, that's one thing. If you want to control an IoT device, there's an easy product for that too. And they even boast that you can create an IoT connected device in less than 3 minutes. And what I've done here is simply played their 3-minute demo, and I'm time-lapsing. I'm making it a little bit faster here. But you can see that you can buy one of their IoT cards for $5, $10, $15, then use their open source, legally available software, download it, change a couple of settings, and immediately here we can see that the web-based app, which you can run from your desktop or your phone, is connecting to this device. So here, when the person clicks this web-based LED switch, we can see the light turning on and off. And of course, that could be a pinout to control a motor, a servo, lights, or something else. And then there's a great website called Fritzing, where if you do enjoy writing software for Arduino and then building these little electronic circuits, you can design the circuit graphically by dragging LEDs and resistors and other components, connect it with wires to an Arduino card, then run your software in a simulator to make sure that it functions the way you want it to function. And then once it's done, you can actually send the design to a company that will print a printed circuit board that you then simply add all these components to. So instead of a breadboard, you'll get a green or a red printed circuit board, a baggie with all of your components, and then you just add them and solder them together. So if you do need some custom designed electronics for a handheld device or for some other consumer device, this is a very cost-effective way to have your own circuit board created. Years ago, this was really out of reach cost-wise and technology-wise. So I'm going to skip ahead a bit here and show this person who went through this process and received the printed circuit board and the components, and all they do is they fit the components into the holes of the circuit board. This is a shield that fits on top of an Arduino. So again, if you need your own custom electronics, you don't need your own semiconductor foundry. You can use these centralized services to do this for you. And you can even test whether it will work in advance. Really fun stuff. So yeah, printed circuit boards and more, and they say 7 business days or less. And then there are all sorts of other practical tips and tricks. Some people might not know that your smartphone actually frequently has things like an accelerometer in it, gravity, pressure, magnetic field measurements, and you can tap into this data for use to export into some kind of app. So you could actually use your phone as a sensor, or you can take this data and connect it to an app that you custom write. So again, you don't need an accelerometer, you don't need a pressure sensor and the code and the display to export it all. You can frequently do this with something as simple as your own smartphone. Really remarkable stuff. And of course, there are lots of applications for app development too. Free open source development environments, which you can use to develop mobile apps. There are all sorts of management tools. And if you're interested in personal management as well, plenty of apps to help manage your project, manage your time, your health, even your knowledge, and more. So it's an enormously empowering era right now. There are lots of resources out there. Not everyone knows about them. I'm glad to put them all in one spot, or at least a collection of them. In another video, I'll talk about the amazing free and open source design software tools that allow you to create the 2D and 3D shapes that you need to send to these companies. They're also really fun and interesting. Now here too is an example of how a maker community might schedule a year of programming. So for example, 2021, we might have a community where January is all about 2D design. And maybe week 1, it's how you design for laser cutting. Week 2 for plasma cutting. Week 3 might be sheet metal. Week 4 might be vinyl graphics for stickers or masking for paints or for other things like that. And maybe you have one meetup a week where you talk about these things. And if you go to all those meetups, at the end of that month, you have a pretty decent understanding of how to design for 2D fabrication. You might not be an expert at using all these tools, but at least you've been informed by what's possible. And then you can take a deeper dive on your own through online learning or even YouTube, or tug the sleeve of a more talented member in your community. Perhaps, July might be electronics. Week 1 might be intro to lights or LEDs. Week 2 might be sensors. Week 3 might be motors. Week 4 might be interfaces. And at the end of that month, you have a simple understanding of basic mechatronic devices. You can imagine how you could create this kind of programming for any community, and you might query the members of your community in advance to make sure that you know you're offering programming people want to listen to. Really exciting stuff. Looking forward to creating some more of these, hopefully illuminating videos. Thanks for listening.